Testing. Here's Professor Thomas with a live video on YouTube. We are going to be doing random problems that have been coming into me. Students have been sending me certain questions, requesting certain videos, and I'd like to go over some of them. I want it to be clear, and there's not too late to ask questions and to get help. The first part is going to start with section 5.3, I believe. So let's take a look at some problems from 5.3. Okay, let's just go through a few of the problems and see what kind of problems they are. We're gonna have to refresh our memory a little bit, and then tackle them after that. Okay, so 5.3, a brand name has a 60% recognition rate. Assume the owner of the brand wants to verify that rate by beginning with a small sample of 5 randomly selected consumers. Complete parts A through D below. What is the probability that exactly 4 of the selected consumers recognize the brand name? The probability that exactly 4 of 5 consumers recognize the brand name is blank. Okay, so this is your typical binomial distribution problem. All right. Let's write out the most important information in this problem, and I will do. Let's get a new sheet so it's clear, and just study notes. It's actually pretty big there. So the first thing we know, it appears that what we're given in this problem is that, let me raise this up a bit. Well, what we're given is that the recognition rate is 60%. So let's see here. I'm going to go over. See if I can get a nice. So my P is 60%. The sample size is 5, so that's N is 5. And then for part A, they want me to calculate the probability of exactly 4 out of the 5. So that means our X is 4. And we use that binomial distribution formula. It was the big formula. It said this, the probability of X. It turned out to be n factorial over x factorial, and then n minus x factorial, and then p to the what did we say, x, and then q to the n minus x power, and that would actually give you the probability. But we also mentioned that you don't have to do this formula. This formula is really too complex. Instead, we can just plug this information into our calculator and get the answer that way. Let me demonstrate. So you have to recognize the kind of problem it is. You'd have to recognize that in 5.3 you're dealing with a binomial distribution, and so they want you to use that binomial probability function to answer most of those questions. Alright, in this case it's at least 4. Or no, it's actually exactly 4. So what we'll do, I'll show you the exact commands you do to handle this problem, okay? You go into second, distribute. You go all the way down to A. Binomial PDF. This is the one where you want the exact amount. Like if you have a group, you know the success rate or the probability rate, and you have some group, and you want the probability of an exact number, not less than, not greater than, but exact. You use binomial PDF, and it's going to prompt me to enter all this stuff in. Um, I have one Stat Wizard, and so Stat Wizard prompts me to enter in the parameters. So let's enter in the information. The number of trials is 5. The probability is 60, so 0.60, and then we're looking for exactly 4. And so this is what you're going to have to paste to the home screen. This is what you'd have to enter in. If you did not have on StatWizard, you'd have to just enter in binomial PDF. You find it in second distribute, put 5, comma, 0.6D, comma, and then the exact amount, 4. .2592. So they just want 3 places. What is the probability that all of the selected consumers recognize the brand name? Well, that's all. So out of n is 5, then that means all 5. I'm just going to do a second entry and change it from 4 to 5. Hit enter. All right, very low, right? 0.077, so 0.078. What is the probability that at least 4 of the selected consumers recognize the brand name? Okay, so this is where it gets a little tricky. At least meaning 4 and 5. Now we already know the probability of 4 and we already know the probability of 5. So the truth is, to calculate the probability that at least 4 of the selected consumers recognize the brand name, it's actually just going to be the sum of these two, 4 and 5 put together, because it's the probability of 4 or 5, which is you simply sum them up. Okay. I will also show you later on, we'll do a problem when you didn't have, what if we didn't have these two? The probability of exactly 4, probability of exactly 5, and then it says what is the probability that at least 4 of the selected consumers recognize the brand name. But since it's at least 4, meaning 4 or more, and it only goes up to 5, we can do this. So I'm gonna add these two numbers together and then just put my answer down. So let me move my calculator over a little bit. In fact, I already have some of the commands on the screen there, so I can just bring them off. And now I will put 0.337. They want it to the 3 places, so 0.337, and that was it. Okay. If 5 consumers are randomly selected, is 4 an unusually high number of consumers that recognize the brand name? Well, again, what was the probability of exactly 4? It turns out the probability is 0.25. That's not unusually high. In order for something to be unusually categorized as high or low, the probability has to be less than 5%. And in no case have we seen that. Even getting exactly 5 of them is not less than 5%. That's actually 7.8%. So what I'll say is no, because the probability of 4 or more of the selected consumer recognize the brand name is greater than 0.5, 0.05. And then the other, they're saying less than, and then greater than. So it's no, because the probability is greater than 0.05. So you pretty much just have to kind of read through it carefully there, and you'll get through it. You'll get through it. All right. I guess we should just keep going. Let's see how far we can get. 14 P's are generated from parents having the green-yellow pair of genes. So there is a 0.75 probability that an individual P will have a green pod. Find the probability that among the 14 offspring P's, no more than one has a green pod. Is it unusual to get no more than one P with green pod when 14 offsprings are generated? Why or why not? Alright, so this term no more than means then that there could be 0 or 1. And that means that we could either find the probability of exactly 0 plus the probability of exactly 1, add those two up, and that would be our probability using the same 5.3 formula. But I'm going to show you now how there's other things we can do as well. Alright, let's bring up our calculator. I'm going to show you two ways to do this problem. It gives us everything. It looks like we're talking about 14 P's. The probability stays the same. So let's just go back into second distribute, go to A, and let's go to A, and then we're going to do 14 trials. Our probability again is 0.75, and we want to know exactly 0 first. Plus second entry exactly 1. Alright, so this is what we got. This is extremely, oh wait, we actually did not get a chance to add them together. They didn't add. Let's see. They look like they were supposed to add, but they didn't. It's not going to make much of a difference though. These numbers are still extremely small. So now we added the two. We added the probability of getting exactly 0 and the probability of getting exactly 1. It's a rare chance. I mean, there was a 75% chance that it was green. Out of 14 of them, it's a very unlikely to happen. But anyway, to where basically they're all yellow. But when we added them together, this is what we got. This turned out to be our probability. Now there is another way to do this. Because it's at most, in other words, it's going from 1 down, we can actually use binomial CDF. The binomial CDF counts for any x value that you want to start with all the way down to 0. So what I'll do is put in 14 trials, probability 0.75, and make sure my volume is up. Let me know, text me if my volume is not up. And there's a chat area. We are live on YouTube. This will be recorded and saved. So if there are any kind of quality issues, let me know. Now, because this is binomial CDF, I want from 1 all the way down to 0. So I'll put in 1, and it will calculate the cumulative probability for me. And it turned out to be equivalent to that previous one. They're both the same. Now what is that? That's 0.000001607, or no, 16018. That's what it is. This number is approximately this number. Like if I hit enter, so the numbers in scientific notation, this is extremely close to 0. It's very, very rare. I don't even know how I'm going to round this off to 3 decimal places. Like if I round this off to 3 decimal places, I'm just going to have to put in 0. Yeah, that was a crappy problem, but we pretty much got it. Is it unusual to find no more than one of them have a green pod? Yes, because the probability of this occurring is very small. It is significantly small, and in fact all we say is once it's less than 0.001, that's 10,000th, then that's it. We don't even it is statistically significant at that point. Let's see. Researchers conducted a study to determine whether there were significant differences in graduation rates between medical students admitted through special programs and medical students admitted through regular admissions criteria. It was found that the graduation rate was 91% for medical students admitted through special programs in all medical schools. Complete parts A and B below. If 13 of the students admitted through special programs are randomly selected, find the probability that at least 12 of them graduated. Now, here's the thing. This is at least 12, which basically means exactly 12 plus exactly 13, the sum of those two. We can also approach this another way as well, and there's a reason why I'm showing you this. So let's say we have our x and we have our probability of x, and we have 0, 1, dot 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 dot, all the way up to 12, and then 13, and then it's cut off. Okay, you with me? Actually, I didn't need to cut this off. This makes no sense. That was probability of x. Actually, here, I'll delete that. So, yeah. So we have our random variable, probability of random variable, and we have 0, exactly 0, exactly 1, exactly 2, exactly 3, dot 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 dot, exactly 12, exactly 13. Now, when it says at least 12, they want the sum of 12 and 13. But also, I will say this, and it's important for you to realize this. I don't want you to get confused. When they say at least 12, that's 12 and 13, we could also calculate the cumulative distribution from this 11 down to 0, and then subtract it from 1, because the probability from 0 to 1, from 0 to 11 plus 12 and 13 will make one whole. So this is a probability distribution, and the sum of all of those probabilities will total 1. So I can do this in a number of ways. I can do exactly 12 and 13 added together, or I can do the cumulative distribution from 11 down and subtract it from 1. It's beautiful when you see it. When you see it, it's very powerful when you see it. Let's continue. So I'm going to do it both ways to be instructive. And let's just start with a clean slate. Alright, so there we go. So here we go. So we're gonna start it off right here. Let me make this a little bit more. I want to be able to see everything here. Now, let's get started first. It says there's 13 students, so first I need to go to second distribute, go all the way down to A, binomial PDF. My trials is 13. My probability of success with graduation rate 91%. So you got to put in 0.91. And my X value, it says at least 12. So my plan is to do 12 first and then do 13 and add them together. So first I'll do 12. Let's paste it to the home screen. Enter. Now I'm going to do a second entry to do 13. Enter. And I'm just going to add them both together now. Plus. And there it is. There is my probability. That's my answer. That's the solution. But what if I said, wait a minute, I'm not done. I want to demonstrate how can I do this using cumulative, the cumulative distribution function this time. And so what I'll do instead, I'll use binomial CDF, and I'm going to calculate the probability from 11 all the way down to 0 and subtract it from 1. So it's really going to be 1 minus, go into second distribute. It's actually B this time, it's not A. Put in 13, and the probability is still 0.91. This is you're really going to either appreciate this or be confused, but I think we'll be more on the appreciative side if it works the way it was intended to work. And so basically we never even saw the probability from 11 all the way down, at most 11, because we subtracted it from 1 to get that 12 or greater. So binomial CDF can handle at most and at least. Yeah, yes. Binomial CDF can handle at least, you just subtract it from 1 to get the other side, or at most, if it was at most 11, all the way down. The same thing, let's report our answer. We want 3 decimal places, so that's going to be 0.671. Suppose a medical school has 13 students in one of the special programs. Does the probability calculated in Part A apply to these students? Well, this is more of a technical question. Suppose a medical school has 13 students in one of the special programs of its medical program. Does the probability calculated in A apply to these students? And it specifically said that the graduation rates between medical students admitted through special programs and medical students admitted through regular admissions was found to be this. So it seems to me that this study was conducted on all of the different programs. So I'd say I would say yes. All right. Let's see. The simple random samples. Okay. Strictly speaking, a random sample has a weaker requirement that all members of the population have the same. B. I don't know. D. What? No, because the students admitted through a single program at a specific medical school are not. Okay. Such a tricky question. Wait a minute. Suppose a medical school has 13 students in one of the special programs. Does the probability calculated in part A? Okay, I guess I didn't read it properly. Such a crazy question. Suppose a medical school has 13 students in one of the special programs of its medical program. Does the probability calculated apply to these students? And we're saying no because the students admitted through a single special program in a specific medical school are not a random sample. So it broke down the criteria for the binomial, one of the assumptions in that. Let's keep going. Let's see, a TV show recently had a share of 30, meaning that among the TV sets in use, 30% were tuned to the show. Assume that an advertiser wants to verify the 30% share of the value, conducted its own survey, and the pilot survey begins with 10 households. So there's N is 10, probability of success is 30. Find the probability that none of the households are tuned in. I'm just going to recall this to the main screen and put in 10. And the share is 30%. And it's 0. And we're getting 3 decimal places, 0.028. And find the problem that at least one household is tuned in. Well, that's the negation of 0. So we'll just do 1 minus the last answer. They all must make one whole. They all must make one whole. And so we calculate 0. So the probability of at least one, which is 1 through 9, the summation, must total 0.97. So let's do 0.972, I think it is. And find the probability that at most one is in the household. So we could do the cumulative distribution. This is alpha B, and we'll do 10, same probability, and this time we'll put in 1 for at most. So meaning actually my probability was off. So at most meaning 0 and 1. The summation of 0 and 1, 0.149. Maybe I should show more work. I don't know. Since here's these are the tough ones though. I hate these questions. If at most one household is tuned to the show, does it appear that 30% share value is wrong? Well, if at most one, well, what I got for at most one was 0.49, so that's actually greater than 50%. I would say this is such a tricky question. Um, does it appear that the 30% share value is wrong? Well, it is still greater than 30%, so I'm gonna go with this. Yeah, I'm gonna go with this. It was a little tricky though. I guess we had to understand the context of the problem. So it's kind of a before you get to go to the next problem, like this is your last like gut check to make sure you really understood it, and um, and it really boiled down to the probability of at most one, and I knew that since this is greater than 5%, then it is correct that it is getting that 30 share that they talk about. Let's see, a certain TV show had a share of 85, and there's 10 households. Same thing. Let's look at another. The probability of a randomly selected adult in the country being affected with the virus is 0.004. 13 samples. What is the probability that the combined sample test for the virus? Is it unlikely? The combined sample is 13 out of 13. So we have let's do this all over. In fact, let me clear out my okay, here we go. Second, distribute. And if this is too small, let me know. I can make this bigger. I don't know what kind of screen you're using, but just communicate with me. And if you get bored and you want me to do some other problems, no, hold on, dang, come on. And where am I? If you get bored and you want me to do some more problems, try to stop me. Try to give me a hard problem. Try to give me a tough problem to solve. Alright, let me pull up my other screens. I got multiple screens here, so I'm able to see a lot of stuff. Okay, here we go. Calculator. Bang. So, we're just going to go straight to binomial PDF. We want exactly 13. So 13. Now, very small probability. And I need to make sure that we are talking about this before I hit enter. This is what the command, but I need to make sure that being infected is 0.004, and is it unlikely for such combined sample to test positive? So testing positive is being infected. So this is the correct probability. Let me hit enter. Oh, so small. So small. Look at that. Times 10 to the negative 32? Are you kidding me? The probability that the combined sample will test positive. It says, wait, no, wait. Note that the combined sample tests positive if at least one person has the virus. Well, I could do, okay. So maybe it's not exactly 13. It's actually going to be, let me run that back. At least I'm going to do 0. I'm going to figure out, let's get this right. Let's do the probability of exactly 0. And then we just subtract that from the last probability. Oh yeah, this was so close. 0.051 is the answer. So close. And I think this is what saved me. Note that the combined sample, I interpreted combined at, I didn't even, let me put it in first. I interpreted combined as all 13 of the sample. And what they meant was if at least one person, this is medical terminology, if one person out of that sample got the virus, then the combined sample has tested positive. And so what I did was, instead of doing the probability of exactly 1, exactly 2, exactly 3, exactly 4, exactly 5, exactly 6, all the way up to exactly 13, and adding them all, I did the probability of exactly 0, got 0.949, and then subtract that from 1, because all the probabilities should total 1, and we should be 0.051 is what we got for that. And now it is greater than 5%. It is so now, is it unlikely for such a combined sample to test positive? I would say it is not unlikely, because the sample test is less than or equal. No, I'll say I like the first choice. It is not unlikely because the probability of the combined sample will test positive. Bam! Let's go. All green, cha-ching. 16. Oh, there's my N. There's my N. My N is 30. My success is 3% rate, defect rate. What is the probability that the whole shipment will be accepted? Well, it's only accepted if there is only one or none. Oh, wow. That's at most. That's at most. They're trying to trick us now. A pharmaceutical company receives large shipments of aspirin tablets. Okay. The acceptance sampling plan is to randomly select 30 tablets. So let me get my notes out. Oh, come on. Now you want to populate. Because I have slow RAM on this. I know I do. And we're sampling 30 tablets. The accepted sampling plan is to randomly select 30 tablets, then accept the whole batch if there is only one or none that doesn't meet the required specification. If a particular shipment of thousands of aspirin tablets actually has a 3% rate of defects, what is the probability that this whole shipment will be accepted? Alright, so we have to carry this out. So our probability of defect is actually 3%, and we have to calculate the probability of X or 1, exactly 0 or 1. That's at most. Which means we get to finally use binomial CDF. Like this problem is made for binomial CDF. I know it is. So let's do it now. So here we go. Let's pull up our calculator here. Second, distribute. Go to B, and our trials is 30. Defect rate is 0.03. That was 3%, and at most 1. So this is going to give me the probability of 0 and 1 put together, from 1 all the way down to 0. So the probability of getting at most 1 is 0.77. This defect rate is 3%. So what is the probability that this whole shipment will be selected? Will be accepted. Well, the probability of it being accepted would be 0.773. This is a similar problem. 23 tablets, the entire shipment will be accepted if at most 2 does not meet the required specification and the defect rate is 2%. What's the probability the whole shipment will be accepted again? So we'll run this one back. Same problem, different numbers. We're dealing with, I believe it said 23, and we're dealing with 2%, and also it's at most 2. And so we're dealing with 0.989. There's a good chance that the shipment will be accepted. Defect rate is small. We're only looking for at most 2. Everything is good there. Now wait, there was another assignment where somebody was, it was like those 2x2 table problems. Let me see if it was it from, maybe it was from 4 or 5. Oh wait, we got a question. 3-2, number 17 on 3-2. Is this statistics, right? We do stats tonight. Yeah, they got a pre-calc. They'll be fine. They got it. They got it easy tomorrow. I'm gonna give them. They got it easy tomorrow. Stats. Let's see. 3.2, number 17. I need to improve this score. Is this your problem? So this problem you can't find anywhere. This is exclusively to the textbook. It's exclusively in this problem. In this problem, they tell you how to do it. So it's actually a little trippy. The average growth rate factor is blank, but they actually tell you how to calculate the average growth rate factor. It says the geometric mean is often used in business and economics for finding average rates of change, average rates of growth, or average ratios. Given n values, all of which are positive, the geometric mean is the nth root of their product. The average growth factor for money compounded at annual interest rates of 9.6, 6.1, and 2.6 can be found by computing the geometric mean of 1.096, 1.60, and 1.026. So we need to calculate the geometric mean of these 3 numbers, which means we need to multiply them together and then take the square root of however many numbers there were. There are 3, so we need to take the cube root. Let's work it out. This is actually a pretty scary problem, though. Let's see. 1.096 times 1.061 times 1.026. Let's make sure we entered that in correctly. And now we have to take the cube root of that number. 5, actually 4, and then last answer is what I'll do. And I got 1.0606. The single percentage growth rate that would be the same as having 3 successive growth rates of 9.6, 6.1, and 2.6 is what? Well, here it says it says the single growth rate, the definition of the single growth rate is found by subtracting 1 from the growth rate factor and then multiplying by 100. So if I were to add up all of these guys, and subtract it from 100%, I should be good. Um, 9, 6. Let's just, whoa, not, I don't need the full screen. 9, let's start with 9.6 first, plus, I'm just going to do it my way. And the last one looks like 2.6. And just subtract that from 100. So I'm getting 81.7. That should work there. I wouldn't worry. I honestly wouldn't worry too much about this that problem. I subtracted it from. This was fine. The single percentage. Did I miscalculate? Ay. Here. Oh. Okay. They want what single percentage growth rate would be the same as having three successive growth rates of 9.6, 6.1, and 2.6? Is that result the same as the mean of 9.6, 6.1, and 2.6? Wait a minute, what? This problem just doesn't read well. This was tricky. It says, what, let me read this over. What single percentage growth rate would be the same as having three successive growth rates? Is that result the same as the mean of 9.6, 6.1, and 2.6? Well, this part, it looks like part C, or another part, so we're not even there yet. This is the single percentage growth rate that would be the same as having three successive growth rates of 9.6, 6.1, and 2.6 is blank. So they want me to subtract 1 from the growth factor and then multiply by 100. So that's, if I subtract 1 and then multiply by 100, I'm getting 6.06. Looks like, and let's go back. So they wanted us to calculate the single percentage growth rate from the average growth rate that we found. And in order to do that, you'd have to subtract it from 1 and then multiply by 100, but basically take this last part. And this is like considered the average. The mean of these, well, that's where you would divide and divide it by. Now when I added them up, come on. One second. When I added them up, you have to add them up and divide by, one second. Well, you add them up, divide by 3. I thought it was like 18 point. let me see. I think it was 18.3, which means 6.1. 6.1. 6.1. 18.3 divided by 3 is 6.1. But where's my calculator? Oh, here it is. It's down at the bottom. The single percentage growth rate is not the same as this. I'd say not, just because it's not. Yeah, that was a little. That took some time. All right, guys, let's do some more. I feel pretty good right now. Yeah, let's see. I'm gonna type in the chat. All right. Now there was, getting back to the problem that I was talking about. I think there was like from 3.4, I want to say. Let me go in there again. I think it's 3.4. I'm not trying to remember. It could be in 4. No. 4.4. 4.4. Let's see. Could this be the one? I have such a bad view of this problem. Let's go back to 100%. Alright. That's actually pretty small. It says the data in the table below summarizes the results of 114 pedestrian deaths that were caused by accident. If two different deaths are randomly selected without replacement, find the probability that they both involved intoxicated drivers. Is such an event unlikely? Intoxicated drivers. If two different deaths are randomly selected without replacement, find the probability that they both involved intoxicated drivers. Well, intoxicated drivers, we'd have to take the sum of this over 114 would be the probability of the first one. So let's do 26 and 38, 64. So we'll do 64 over 114 times 63 over 113. I got 0.313. Is it unlikely? No, because the probability is greater. If 3 different depths are randomly selected without replacement, well, because we're not replacing them, you have to take one away from the total each time. The first time it'll be out of 146, the second time out of 145, the third time out of 145. Well, this just looks like 242 over 2658. Let's jump on to 5-2, number 16. And they don't want, see, in our test you can put it in a fraction. You don't even have to simplify it. And I don't think it does it for you. Like if I put in 242 divided by 2658, it's not going to simplify it. You have to actually have it in your calculator. Let's look at 5-2, number 16, and I'm trying to remember what 5-2 was about. And it was a new chapter, maybe 5-2 distributions, maybe. Let's see. 6. It'll come back to me. Ah, okay. 16. Which one was it? My 16, was it number 16? Because I know it's not this one. This is just a true false. But wait, let me take a look at this one. Find the probability of exactly 4 Mexican American jurors. Well, exactly 5, I mean. Well, 5 is right here, 0.003. Find the probability of 5 or fewer. So that's 5 all the way down. So it's going to be 0.004. I have to add the 5, the 4, and these are just zeroed out. Which probability is relevant for determining whether 5 jurors among 12 is unusually low? The result from part A or part B? Well, we could just say the truth is I would accept both choices. I wouldn't answer a question like this. They're both less than 5%. So which probability is relevant for determining whether 5 jurors among 12 is unusually low? Part of me wants to go with the cumulative from 5 all the way down to 0 because of the negation, 6 or more. So I think it's probably best to go with B because of the negation. But if you go with A, what about 4? What about 3? What about 2? We won't know if it's low or not. But if we go from 5 all the way down, we have a better understanding of the distribution. So that was actually a pretty good question. Let's look at number 6. In the accompanying table, the random variable x represents the number of televisions in a household in a certain country. Determine whether or not the table is a probability distribution. If it is a probability distribution, find its mean and standard deviation. Okay, well, in order for it to be a probability distribution, the sum of all of these must total one whole. Let's add the first column. I'm looking for pairs of 10. 3 and 2 is 5, and 5 is 10. 8 and there's 10, that's 20. So the first column adds up to 20. Carry the 2, and I'm going 2, 3, 5, 7, 9, plus another one is 1. So it's true that the sum of all these do make one whole, exactly. That's good. What else do I need to know whether or not it's a probability distribution? Well, everything else checks out. I mean, that was the main thing. The context of the problem, we're dealing with a random variable, and everything else seems fine. So now the question is, let's find the mean. And the way you find the mean is you multiply the x by the probability, add it with 1 times that, plus 2 times that, plus 3 times this, plus 4 times this, plus 5 times that. And one thing I suggested was using your calculator into 2 lists. So let's enter the data. The shortcut would be, let's enter the data into 2 lists. My first list, I'll put in the x values. 0, 1, 2, 3, 4, 5. And there was only 5. I'll put in the probability in the second table. And list 1 and list 2. And now we're going to use the one var stats. So go to stat, calc, one variable stats, put in list 1, and we actually have a frequency list. It's not really a frequency list, but you know, it will work. Put in second L2, hit calc, and it will give us the mean. The mean, and it even gives us the deviation. Sigma x is 1.29. The mean is 2.79. So I'm going to put that in. 2.79, but if you round it, 2.8. The deviation, the standard deviation, rounding it to the nearest tenth is 1.3. I think I answered your question. That should have answered your question, guys. Let's keep going. What would be the mean here? There's really no shortcut way to do it. You have to multiply it, add, multiply all the way, and then divide by the sum of that column. So the usual number of girls would be anything greater than 5%. So from 7, the maximum number of girls we could get, we can expect a 7. Oh, no, come on. Oh, they want me to use the mean and the deviation. I can't just use the probability distribution. Okay, so you'd have to find the mean, you'd have to find the deviation, and then you calculate the mean plus two deviations above. So whatever the mean is plus 2 deviations above. Now this would be a lot to enter into the calculator. We probably could do this right away in Excel. But again, it's just a range rule of thumb. So what you're doing is once you find the mean and the sample deviation, you're good. You can then find the, and you know, in Excel I might have a hard time because this is a probability distribution and I'm not sure. I probably, it's so much easier with the calculator. In fact, I should just use the calculator for this one. But I think everybody's good with this one. So I'll probably just move on. Again, they want that mean again. They want that mean. They want that mean, and then they're probably going to want the standard deviation. So 5.2, yeah, just hammer away at it. Just use your calculator again. Just, you know, spend some time and just enter those buttons in there. You'll get through it faster that way. You don't want to do nothing too fancy on that. All right. If there's not any other questions, guys, we'll probably wrap it up. I didn't do these. These are just too obvious. Suppose the class average has 86.5 and then standard deviation is 4.5. Would it be unusual to get a score of 97? Well, is 97 2 deviations above? Well, 4.5 times 2 is 9. 86.5 plus 9 is still going to be less than 97. So yes, it is unusual. Be sure to make your histogram here, okay? And what if you had the data and you had to create the frequency table? So keep in mind those steps. And what if you had to create a frequency table with only 4 classes or 5 classes or 6? How would you approach it, right? Remember, you take the high and the low, divide by the number of classes you want, and that you use that for your class width. Let me check if there's any other questions that some people have requested. I always do that when it's over, then I realize, so I forgot to do this question. Who's out there Who's still watching? Did I get to your question? I was going to wrap it up. Yeah, I heard quiz 2 was quiz 2 did was quiz 2 really fast? Let's see, it was an hour and 20 minutes. Yeah, this seems pretty tough. The principle of redundancy is used when system reliability is improved through redundant or backup components. Assume that a student's alarm clock has a 5.8% daily failure rate. What is the probability that a student's alarm clock will not work on the morning of an important exam? So I'll say if the student has two such alarm clocks, what is the probability that they both fail the morning of? Well, wouldn't it be 0.058 times 0.058? Hmm. Yes, I see, Holly. What if we had to change on the test you're talking about? I think I know what you're talking about. Well, they won't let me go on until actually done, so I'm just gonna choose a number. I remember doing one like this. You haven't seen the scores yet. Correct, wrong, correct. Um, right, right. Yeah, I was talking about. Okay, so here, um, this is already given. The frequency distribution is given, but what if you had your own data set? What if you had a data set of 20 numbers and you had to make your own distribution table and you had to make it with exactly 6 classes? How would you set it up? And that was something that I was posing. You'd have to put your minimum, you'd have to know where you want it to start, and you want to know what is the class width, and then that would be all. And then after that, you just total up the number of data points that's in this class, the number that's in this class, so on and so forth. And that formula was you take the highest number subtracted from the lowest number, and divide by the number of classes that you want. So that's one way to get it. Yep. Alright, I think we will probably wrap it up soon unless there's any other questions. Yep. I think this has been a good session. Not much else I can really say other than, you know, you can have a note card. You can use your calculator. And you should be good to go. You should be fine. You're good to go. Okay. It seems like there was a question. I put the list in my calculator for the probability distribution, cannot get the correct answer. Yeah, you're going to start with 0 and then go all the way down for list 1. And then put in your probability in your second list. And then the next important thing is to use second stat. You go to stat calc and they do one var stats. And you got to have L1 and L2. And it could be that, check your lists carefully. If there was a single mistake in one of your lists, then it would be off. So just go back and edit. I'm going to type this in. You guys can come at 6:45 if you want. So yeah, good job guys. You guys did excellent. Yes, I'll be in there. All right. I'm gonna sync the grades. Let's see where everybody's. Oh, I'll wait until midnight. If I'm still up, we'll have those grades synced for you guys tomorrow. Good luck. Have fun with it. Let's get a nice good A. Yeah, no problem. Rest easy, no worries. I'll be fine. I think people are doing really well. Really, really well. The stats is such a crazy class. There's so many things going on in stats. Makes it pretty tough. Just hang in there. I think we're going to sign it off now. Thanks for watching. And I think we'll call it good. I'll post the link when it's done processing. Probably this link will be available tomorrow. Takes a while to process. Good night. Bye-bye.